I'm actually recording this. This is actually my 7th video on reviewing of solving equations, and I've been building from the first video all the way to this last video, which is going to be on solving equations that require simplification. Obviously, what does that mean? Distributive property and combining like terms. And they're also involving fractions and the distribution of fractions. Okay, so let's jump right in with the basic equation. Let's go ahead and copy this one down. 2/3 x plus 6 equals -2. And you probably are noticing that I have it written twice. That's because I want to do it 2 different ways. And whichever way you prefer, that's what you could do. So as you can see, this equation is already simplified. If you look at the left side of the equal sign, if you look at, let me cover this up real quick. If you look at the left side of the equal sign, there's nothing to do. There's no distributive property, no combining like terms. If you look at the right side, there's nothing to do. That's already simplified. That's a nice, beautiful integer, -2. So this is what we call a simplified equation. So then we move on to the goal to get x by itself on one side. You want x's on one side and the numbers to the other. X is clearly on the left side of the equal sign. Okay, so you want to get this x by itself. So you have to get rid of the 2/3 and you have to get rid of the 6. So what would you guys want to do? Get rid of the 2/3 first or get rid of the 6?
2/3.
Okay, so a lot of people say the fraction, right? They're like, I hate the fraction, I want to get rid of the fraction. All right, this will work, even though I wouldn't go with this, but this will work. To get rid of any fraction, you got to multiply everything by the denominator of the fraction you want to get rid of. In this case, you're going to multiply everything by 3, okay? And that means that you have to multiply the 6 by 3 and the -2 by 3. Everything has to be multiplied by the denominator of the fraction you want to get rid of. Keep in mind, if you had more than one fraction, you could multiply everything by the LCD. That way it'll get rid of all fractions at the same time. Anyway, we are multiplying everything by 3. And of course, that eliminates the 2/3. You end up with just 2x. Why? Because originally it was a 2 divided by 3. And the opposite of dividing by 3 is multiplying by 3. So that gets rid of the fraction. So what do I have left? I have a 2x left. And then 3 times 6, that's 18. That's a positive 18. Of course, bring down the equal sign. And -2 times 3 is -6. Okay, so we now have gotten rid of the fraction. Now let's get the x by itself. What do I get rid of first, the 2 or the 18?
18.
The 18, right? How do you remember that? What's important is the x. X is like the movie star, right? That's what's important. The 2's with the x, kind of important, kind of like the movie star's buddy. This guy's the loner. You don't care about this guy. It's all by himself. Let's get rid of this guy first. So you get rid of that plus 18 by subtracting 18. And what you do to one side, you must do to the other to maintain the equality, maintain the balance of the equation. So we have 2x, bring down the equal sign, and over here, you owe 6, you owe 18, you're going to owe 24. So that's a -24. Okay, so what does that really say? That really says 2 times x equals -24. And the way to get rid of multiplication is with division. So you divide, and when you do to one side, do to the other, you have x equals -12. Everybody should know how to do that already. That's one option that I see a lot of students doing, okay? They immediately get rid of the fraction because they don't like fractions. You could do that, that's fine. However, notice that on this equation, I ended up multiplying this by 3, which canceled this by 3 and this by 3. It might be a little easier to, instead of jumping right in and say, oh, get rid of the fraction, think, is there anything easier that I could get rid of? Yeah, this plus 6, I could get rid of it easily by doing what? Subtracting 6, that's right. And what you do to one side, you must do to the other. So what you end up with, equal sign comes down. On the left side, you have the 2/3 x. And on the right side, you have -8. Because -2 minus 6 is -8. So here's your new fraction. It's smaller than the original. And now you can worry about getting rid of the fraction by multiplying both sides by 3. So you only have to multiply this by 3 and that by 3. And you end up with 2x equaling -24. -8 times 3 is 24, -24. And you get rid of the multiplication of 2 by dividing by 2 and dividing by 2. And you get the same answer. Okay, I just think it's slightly faster moving things over and only having to multiply 2 things instead of 3 things by that denominator 3. But it's totally up to you. Anyways, that's not the main point of today's video. How about this one right here? This is where I want to get to. Go ahead and copy this one down, please. So on this equation, we could distribute this fraction, right? -2/3 times x, you get a -2/3 x. And 2/3 times a -1, you're going to get a positive 2/3, but you're going to end up with more fractions, right? So I think it's a little easier to get rid of the fraction by multiplying everything by the denominator of the fraction that you want to get rid of. In this case, 3. So if you multiply by 3 and you multiply the x by 3 and the 5 by 3, everything by 3, it'll cancel out the fraction. However, I know you're thinking, wait a minute, Salgado, you just said that you want to multiply everything by 3. You didn't multiply the x by 3 or the -1 by 3. But the reality is I did. Because whatever you do to this guy right here, it's kind of like doing it to those guys right there because of the distributive property that exists. Does that make sense? Right? It's like whatever I do to this guy, it's like if I did it to those guys because of the distributive property. Okay? So in reality, I really did multiply everything by 3, even the x and the 1, but I don't actually physically go in there and put an x times 3 and a 1 times 3. That would be incorrect. So the beauty of this is that the fractions eliminate and you end up with a -2 in the front instead of a -2/3 with the x minus 1 equals 3x plus 15. And then after that, it's simple. You distribute -2, that's a -2x. That's a positive 2. Bring down the equal sign, bring down the 3x plus 15. And then you want to get x by itself on one side of the equal sign. Problem is you have x's on both sides. So at this point, you got to make a decision. Do you want your x's to be on the left side or x's to be on the right side? And if that's the case, if you're like, I want x's on the left side, that means you want the numbers on the right side. So you decide if you want x's on the left, numbers on the right, or if you want x's on the right, numbers on the left. So what do you guys say? Move the x's to the left or to the right? To the left. Okay, so I'm going to get rid of the 3x by subtracting 3x. And what I do to one side, I do to the other, subtract 3x. So your new equation is going to be a -5x plus 2 equals, that cancels out 15. And you want to get x by itself, so you're going to get rid of that 2 before the -5. So you go subtract 2, cancel, subtract 2. You're going to end up with -5x equals 13, which means that that's really a multiplication of -5 in front of x. So you get rid of that multiplication by dividing by -5, dividing by -5. And that's your final answer. You can't really do it. X equals, you can put the negative sign in front, 13 over 5. Or you could change that to a mixed number. How? 13 divided by 5, how many times will that go in? That'll go in 2 times with the remainder of 3 over the original 5. So you could write it like that as well. Let's jot this one down. What? Look at that. Insane. I just made this up. It's probably going to be a disgusting answer, crazy fraction, but let's go with it. Now, what's confusing about this? Obviously, all these fractions. One option is to distribute the -1/4 times the x, a -1/4 times the 5, and get more fractions and distribute the 2/3 and get more fractions. We even have fractions on the outside of the parentheses. So I say we get rid of fractions. How could we get rid of all fractions at the same time? Multiply everything by the LCD. So what would the LCD of all these 3 denominators be? 4, 3, and 6. 12. Okay, 12. How do I recommend for you to go about this? Go to the one with the biggest denominator, 6, and see if you could change the smaller one to become that bigger one. And yeah, right here, 3 times 2 could change to 6. The 4 cannot change to 6, right? But if this would have been a 2, then yeah, the LCD would have been 6 because all of them could change to 6. So if it didn't work, double it. 6 times 2 is 12, and then ask yourself, could I change 3 to become 12? Yes. Could I change 4 to become 12? Yes. So 12 is the LCD. So if I multiply everything by 12, this times 12, this times 12, this times 12, and this times 12, it'll get rid of all fractions at the same time. Multiply everything by 12. And once again, you're probably thinking, wait a minute, why didn't you multiply x by 12 and 5 by 12? You don't do that because whatever you do to this outside guy that you're going to distribute, it's like if you did it to those inside guys. It's almost like if the parentheses protect these from the multiplication of 12. But in reality, you are multiplying them by 12 by multiplying this outside guy by 12, because whatever you do to this outside guy, it's like if you did it to those inside guys because of distributive property. Okay. Anyhow, what do I end up with? The 12 divided by 4 is 3, so I'll end up with a -3 on the outside of the parentheses. A -3 on the outside of the parentheses. And then we have the 12 times 1, that's 12, so plus 12. Bring down the equal sign. And then right here, 12 divided by 3, that's a 4. And of course, 4 times negative 2 is a negative 8 on the outside of the parenthesis. And the x minus 1. Again, we didn't multiply these guys by 12 because whatever I do to this outside guy, it's like if I did it to those inside guys because of the distributive property that exists, right? And then finally over here, last but not least, the 12 divided by 6 is 2, and 1 times 2 is 2. So we're going to put a plus 2 right there. And now we have a fraction with no more an equation with no more fractions that we could distribute and combine like terms, all right? So we need to simplify each side. And when I say simplify each side, I recommend for you to cover up one side and just focus in on one side at a time. So on the left side, do we have any distributive property? Absolutely. We have the negative 3 times x, that's a negative 3x. We have the negative 3 times positive 5, that's a negative 15. Bring down the plus 12. So I have distributed. Now I need to try to do combining like terms. Out of those 3 terms, 1, 2, 3, the last 2 could be combined, the minus 15 and the plus 12. When you combine those, what do you get?
3 negative.
Negative 3, that's right. So we have a negative 3 with the negative 3x in front. And that is completely simplified on the left side. I distributed, I combined like terms, this is simplified. I can't do anything else with the left side of the equal sign. So I'm gonna take that equal sign, bring it down right here. Notice that it keeps coming down, separating the left side from the right side. Now that I've simplified the left side, I'm gonna focus in on the right side and simplify on the right side. The negative 8 distributed times x is negative 8x. Negative 8 times negative 1 is a positive 8. And of course, we're gonna bring down that 2. And out of these 3 terms, I could combine the terms that are alike, in this case, the 8 and the 2. So if I combine 8 and 2, I will get 10. And that is a positive 10. What about the negative 8x? There's nothing to combine it with, so just bring it down. And you're going to have negative 8x. So this blue equation here is our new simplified equation. And we need to get x by itself on one side. So at this point, you need to decide, where's x at? Left side or right side? It's on both sides. I need to move all the x's to one side or the other. So do you want to move the x's to the left or to the right? I would go to the left on this one. Why? Because I have a negative 8x. And to get rid of a negative 8x, you would add 8x. And when you do to one side, do to the other, add 8x. And you will end up with a positive 5x. That's a nice positive 5x. Bring down the minus 3. Bring down the equal sign. Bring down the 10. And there's your new 2-step equation. We're almost done. How do I get rid of the minus 3? Plus 3. That's right. That cancels out. What I do to one side, I do to the other. I end up with 5x equals 13. Okay, let me make some space here. Whoops, that didn't work out. 5x equals 13. And final step would be to get rid of the multiplication of 5 by dividing by 5, and x equals 13 over 5. And there's my answer.